All right, so number 5. Sorry. In the figures above, lines L and M are parallel, and y is equal to 20 and z is equal to 60. So what is the value of x? So this kind of just tests your knowledge of geometry, triangles, things like that. So I'm gonna kind of like fill in what we know. So if y is equal to 20, we know that this is 20, and if z is equal to 60, we know that that is 60. Now, in order to get x, you need to know that when you have two parallel lines and you have one intersecting, the angles here and here are going to be equal. So if you look at the picture, this one and this one are going to be equal. So on this little triangle, I'm drawing the one over here. We know that this is going to be 20 from this one over here, and we know that this is going to be 60 from the measurement that it gave us in the stem of the problem. So now all we have to do is figure out x, and that recalls on the last geometry principle of this problem, which is just knowing that in a triangle, all the angles in a triangle add up to 180. So in order to find the missing one, you just subtract 20, you subtract 60, and that is not too bad. You get 100, and that's your answer. So it's really important to just know those simple geometry ones, only because I know that it's like kind of way back when we did this, but at the same time, and for those of you who haven't taken geometry yet, you guys are going to learn this. But for a lot of the seniors at least, it's been a long time since we've done it, but a lot of them are not too bad. There are harder ones 100%, but some things like this are not impossible. So I'm going to move on to the next page. All right, so let me see which ones I want to do on here. Really the only important one that I wanted to do, yeah, the one that I really wanted to do is number 8, because it's a weird one. The number 6 and number 7 are system of equations and just slope, which we've done before in previous sessions. So I'm not going to waste my time on that just because it's something I think you guys know how to do. So number 8. In the equation above, which of the following is a possible value of x plus 1? So at this point, you're probably kind of tempted to, move things around. And I think this is what I was tempted to do when I first saw it. Move the x plus 1 to the other side over here so that you have a 2 over there, and then solve for x and then figure out what x plus 1 is. Well, you can do that, but this one can actually be done much easier. And I'm going to show you guys how to do it. So in many cases, it's actually easier to just go through each answer and see which one works and which one doesn't work. So yeah, I'm sorry, my house phone is ringing, so you may hear that in the background. So what I'm going to do, and it's only asking you for a possible value of x plus 1. So really, all you have to do is plug in each of these answers and see, plug in each of these answers in for x plus 1, which is just like a whole variable. You can just treat this like an x. We'll call it another letter, like y, or something like that. But that's essentially what you're going to be doing for this problem. So let's see. I'm going to plug in C and D first, just because those are easier to plug in. So when you plug in those, you get that 2 is equal to 2 over 2. That can't be true, so it's not this one. You get 4 is equal to 2 over 4, and I'm just plugging in each of these values for x plus 1. And that can be true because 4 is not equal to 1/2, so we can already get rid of those. So you're essentially left with A and B, which are obviously harder to work with just because they have radicals in them. So really all you have to do is plug in 1 and just check to see which one actually works. I'm going to plug in B just because, at least when I'm doing the math, I'd rather plug in the one with the less steps or the less work first and just get those out of the way before doing the hard ones, just because this is a time crunch and you're just trying to save as much time as possible. So let's see. Radical 2 is equal to 2 over radical 2. Well, I know at first it doesn't really seem like it could be true, but really you kind of have to manipulate this side of the equation to see if it can be. And in order to manipulate, I just like the radicals all in the numerators and none in the denominators. So what I'm going to do is I'm just going to get rid of the radical in the denominator of this equation. When you do that, and I'm going to answer the question right now. So when you do that, you end up getting 2 radical 2 because you have to multiply the numerators over radical 2 times radical 2. And any radical squared is just the number inside. These two cancel out. So radical 2 is equal to radical 2, which means that B has to be the answer. Now, I saw a question asking why you don't add 1, which is, I'm assuming, this part of the equation right here. So the choices in the problem are asking you for a possible value of x plus 1, not x. So essentially, when it's giving you radical 2, 2, 4, all the choices in the problem, I'm sorry, I clicked the wrong tab. It's not asking you to solve for x, and these are not possible values of x. It's possible values for x plus 1. So you don't need to add the 1 because the 1 is already being added. You know, essentially, like, this equation can be rewritten as this because, you know, it's not really, the 1 is not really important in this problem. You know, it would be if we were doing, as I was saying before, we were moving things over and then we were doing a lot of things. So, yeah, that's just what, it's important. I think that's if you're doing it the other way, which you can do because you do have access to a calculator, so it's not going to be as hard. But yeah, that's essentially what you'd be doing. So I'm going to clear the page for this one. And I'm going to move on to the next page. I want to do both the problems on this page because number 9 is kind of interesting and number 10 is really interesting just because it's not even a math question. It's just like a real life problem kind of question. So let's see. It says, and it's going to be, you're going to find that maybe 2 or 3 questions will have actually like 3 questions that go with it. So you're going to find that maybe twice or 3 times per section, or at least more specifically on the calculator section. So let's look at this one. It says questions 9 through 11 refer to the following information. It looks like a cup. It says that the volume of this cup-like figure, or glass, as it says in the problem, is represented by the equation 7 pi k cubed over 48. And it's saying that the glass can hold a maximum volume of 473, which is approximately 16 fluid ounces. So what is the value of K in centimeters? That's the first one. So really, all you have to do is plug in the volume that you do know, which is, let me just, 473, into the volume equation right over here. And this is not too bad at all. So really, and this is really when you want to use your calculator, because if you were to do that like on paper, it would just take so much time. And this is really, really, really when you want to just plug that in right away. So we're going to manipulate it and then solve. So really, since there's a 48 in the denominator, that's the first thing we get rid of. We multiply by 48 on both sides. When you do that, you should get 22,704. And then you still have 7 pi k cubed. So now what I'm going to do is divide by 7 pi on both sides. And this can be easily done with the TI-84, like with calculus and pre-calculus, like the ones that we use for those classes. But if not, you can always just do 7 pi on the side and just give like an approximation, because you don't need to do everything precise. And when you do that, you should get like around 21.99. So let's just divide 22704 by 21.99. When you do that, and I'm going to continue writing it over here, you should get 1032.469. And then we're left with a k cubed over here. So now all we have to do is take the cube root of this, and then that's how we would get our answer. For those of you who are using a different calculator, I'm trying to figure it out. So the cube root, when you have this, I'm not, I know that there's a square root command on the TI-84 plus CE, but what I do is I raise the whole thing to the 1/3 because that's how you get the answer. And I don't remember where the cube root function is right on here. I know where the square root one is, but I don't know where the cube root one is. And on the other calculator that's also really popular, the TI-30XA, it's like a gray one. Really all you would do is the same thing. You could raise one of your things. I think it's the y to the x function. Let me just make sure. Yes, it's the y to the x function. So when you do that, let's say you have 1032.469. I'm gonna use the y to the x function. It's all the way on the right, and since there's no cube root function on here, like right off the bat, I'm gonna use the a b over c function to put in the fraction, which is gonna be 1/3. And for those of you who like are not understanding, it's just because x cubed can be, or sorry, the cube root, in order to convert this to a regular number, it would be x to the 1/3, because you take the x1 on the inside over the x1 on the outside, which is 3. So that's why we're putting everything to the 1/3. So when you do that, you should still get the same answer, 10.1. And if we need to do a calculator workshop, just because I know that it's we don't usually use the calculator in this way, I'm really happy to do it. So that's just really how you do that problem, and it's just pretty much testing your calculator knowledge. So as I was saying, some questions do not require the calculator, some do. So that's that. All right, and number 10. It says water pours into the glass slowly and at a constant rate. Which of the following graphs best illustrates the height of the water level in the glass as it fills? So this is a weird problem because you can't really do any math to get it. You kind of just need to know how water fills in a cup in order for it to make sense. And when I was doing this problem, I was like, wait, first, but then I kind of realized like what I was asking. You just need to know that when they're filling in the water at a constant rate, so it's going to be still like dropping in at the same points. Since the cup is like much, and I need to draw that better. Since the cup is like much more thin at the bottom, and this is like a more exaggerated picture, at least when it's originally filling up, and this is like the water, it's going to start rising much quicker. But as the cup starts to expand and get wider, it's obviously going to take more time for it to fill up that whole space, because there's more space now, there's more volume. So what kind of matches what we were saying? Well, it's not going to be a constant rate, because if it was like a perfectly cylindrical cup, then it would be a constant rate. So that's no. It's not going to be just like a straight line, because that would just imply that the height is not changing whatsoever. So I don't think that's true. And now we're just in between B and C. Well, just from B kind of indicates that it's going to be kind of like steady at first and then kind of really speed up the height, but that's not true. Like we said, if anything, it's not going to increase as we get higher and higher and higher, or as more time passes by. As more time passes by, it's getting closer to the wide point, so it's going to take more time for it to fill up. So this is wrong, but this one is right, because at first it matches that it's going to be kind of very steep at first, and it's going to fill up very quickly. But then as we get to the wide points, the height is going to take longer to increase, because there's more space, there's more volume. So I don't know how hard that one really was, but it's weird because you don't really see questions like that on the SAT math. So yeah, that's why I wanted to do that one. All right, so let me see which ones I want to do here. I think I'm gonna do number 13 and number 14. Number 11 goes with the previous question, but I think we've seen enough of that problem. So if a to the negative 1 over 2 is equal to x, where a is always greater than 0, what is a in terms of x? So this problem, we really just have to solve for a. That's really the only requirement of this problem. So all I'm going to do is just manipulate this so that we can solve for a. And it seems simple, but sometimes we don't know how to manipulate when there's a negative exponent or when there's things like that. So it's going to be like a review on that. So let's see. A to the negative 1 over 2. Well, a to the negative 1 over 2 can be rewritten as, oops, sorry, forgot to freeze the screen. It can be rewritten as 1 over a to the 1 over 2. Because when you have a negative exponent, you need to know that the equivalent of that exponent is 1 over the positive version of that exponent. And that's going to be equal to x. This can be rewritten as a radical a, because going back to our converting principles, in order to make this into a radical, we put the exponent, the numerator on the inside and the radical on the outside. But really, the radical just means it's going to be the square root, so you don't need to write the 2. So that's that. Now, the next thing I would do is I would move the radical a, or I would move the radical a to the other side, because whenever there's a variable in the denominator, it just makes things like very, very ugly. So yeah, I'm gonna move this over, multiply both sides, and then when you do that, you get that radical a x. So now we're going to be solving for a, because it's saying what is a in terms of x. So how do we do that? We have to move the x to the other side. So you end up getting 1 over x is equal to radical a. And now the only thing we have to do to isolate the a itself is to square this. So when you square that, remember, when you're squaring it, it's like you're doing 1 over x, 1 over x. So when you do that, you get 1 over x squared. This ends up being, a ends up being 1 over x squared, equal to 1 over x squared. And that answer is C. So this is just a review of your manipulation with negative exponents. It's not too bad, but yeah, it's just there just in case they want to test you and trick you to see if you know it. So let's look at number 14. So which of the following is the value of x for which the expression is undefined? I'm not going to read the expression. All right. So it's really, really, really important to know that in math, at least when you're given a problem like this, an expression is undefined when your denominator is equal to 0. So really, we need to find when this denominator is equal to 0. So all you have to do is set this equal to 0. And how do we do that? How do we figure out when it's equal to 0? Well, all we have to do is factor. I think that a common factor that goes into both is 5 and negative 2. So really, this can be rewritten as x plus 5 and x minus 2. So when x is equal to negative 5 and when x is equal to 2 is when it will be undefined. So I'm not seeing a negative 5 there, but I do see 2, so that's the answer. So it's just kind of knowing really those key terms as well, because I know that we all know what a factor for the most part, but we know sometimes someone may not know when something is undefined, so it's just important to know that. So let's look at the next problem. All right, so on this page, I wanted to do number 17 because it was stats. The rest is not too bad, in my opinion. So I'm gonna do number 17 only because it's mean, median, modes. It's kind of just testing your knowledge of stats. So it says, the table above shows the distribution of ages of 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? So at first glance, you may be prompted to like put everything in your calculator and just calculate, but it's just that you shouldn't do it that way. I'm gonna kind of draw the graph of what this would look like, the distribution, because there's a really important stats rule. So at least looking at this, you can tell that there's gonna be like the ages, 18, like 20, whatever, going up. And then I'm gonna draw the frequency. So the highest frequency is 18, and then it's like 19, and then 4, and then 2, and then 1, 1, 1. So I'm gonna draw this as a statistical curve, and I know that this data set is skewed right. And from that knowledge, you can actually find the answer very easily, because in a skewed right distribution, you have a lot of big values pulling your data sets. And I'm sorry, my phone is ringing again. That's my bad. You have a lot of big values pulling your data sets to the right. Notice how like the curve is going this way. So really those values, even though most of the values are at 18, that is really where most of them are. You have a lot of weird outliers like 30, and that's gonna pull everything to the right. So really when you do the average, even though you have a lot of 18s, the 30 will affect the 18s and it's gonna pull it to the right. So your mean is gonna be closer over here. Now, the mode is just where the highest data set happens. So obviously the peak is where that happens. So the mode would be over here. I'm gonna do this in a different color actually, just because it's a little bit, it's not as clear. So this is gonna be the mode. The mean, I said it's gonna be somewhere over here just because the data set is being pulled. So where's the median? Well, the median is just the middle number. The median wouldn't necessarily be affected by outliers unless you have like really a large amount of them. But really, if there's a lot of 18s over here, and then you have some 30s and like 28, whatever over there, the middle, for example, would still be 18. So the middle would still be in the middle of the data set essentially. So I'm gonna say it's like right over here. And from that knowledge, and this is just, I know it's very tempting to like want to calculate everything, and this is just even like kind of going over it. If you just kind of draw the picture, you can just kind of visualize it like that without me having to explain. So now that we've written everything down, the only one that's plausible is A, because the mode, of course, is the 18. The median is going to be somewhere like around here, and then the mean, of course, is going to be pulled higher than the median because those large data sets are affecting an average, but they're not affecting a center value. So that would be A. This is like pure stats. If you are considering taking AP stats, which may not be your case if you're like a freshman or sophomore, but if you're an upperclassman, this is a lot of what it's about. So yeah, I'm gonna move on to the next problem, but it's definitely gonna help you when you're taking your SAT while also being in stats too. So let's look at the next one. I'm gonna do number 19 because number 18 kind of looks like something we already did. So let me look at number 19. It says the range of the polynomial function f is set of real numbers less than or equal to 4. So remember, range is y values, and it's saying that the y values are 4, and then they just keep going down. So if the zeros are -3 and 1, which of the following could be the graph of y is equal to f of x? So the first thing I'm going to do is eliminate the ones that don't have a range of 4 or of numbers less than or equal to 4. And it's not this one because this one goes to infinity. This one also goes to infinity, so it can't be those two. So we're left between these two. So now we're going to just test the zeros. So at which points or which graphs are at -3 and 1, where is it equal to 0? Or which ones have those values equal to 0? Really, the only one that has that is here. This is -3. This is 1. So that's the one. That's the answer. So this one wasn't too bad, and I know you guys can notice this already, but half of these problems do not require a calculator whatsoever. So that's really important to just know. You don't always need to depend on your calculator. It's just there just in case. So let's go on to the next. I'm trying to make it to the long response questions because those are the ones that I always like doing with you guys. I don't think the ones here are as important as the other ones. I'm trying to look. Sorry, I'm just trying to make it to the long response ones. I don't think these either. I'm gonna do number 25 just because do a percent one. All right. So I'll do since you guys want me to do a percent one. Yeah, that's right. I don't think I've done one of those before. I'll do number 22, or I'll do number 21 and 22 just because extra practice with that. So it says between 1985 and 2003, data were collected every 3 years on the amount of plastic produced annually in the United States in billions of pounds. The graph below shows the data and the line of best fit, which is similar to what we've been seeing. There's a lot of line of best fit. The equation of the line of best fit is that equation where X is the number of years since 1985 and Y is the amount of plastic produced annually in billions of pounds. So which of the following is the best interpretation of the number 3.39 in the context of the problem? So it's just asking you to interpret slope. And the reason why I'm doing this one is because I'm assuming I don't want to do this one because it may connect with 21. So that's why I think it's important. Let's see. 3.39 is the slope. It's very clear. That's in Y. It's in the slope intercept form. So it's definitely the slope. And an interpretation of slope is whenever the X value increases by 1, the Y increases by 3.39. So let's see which one kind of says that reasoning. So the amount of plastic in billions of pounds, no, definitely not. That is definitely not the answer. That could be the answer if it was asking for this, because that would be the amount that was there from the start. But no, that's not the answer. That would be the y-intercept. The number of years it took, no, just make sure that your units are matching up. 3.39 is going to be in billions of pounds because that's what it's going to be translating to. So it's definitely not years. X would be years, but remember, the slope is what's affecting your Y value, so it can't be that. The average annual plastic reduction in billions of pounds in the United States from 1985 to 2003. I see why that one is like not as, oh, this is definitely wrong. It's definitely not one that I would completely rule out, but it doesn't really match a slope for me. So I'm gonna just hold on to it and see what D says. The average annual increase, so I'm already liking that because it kind of relates to slope. In billions of pounds, it matches the unit, like we said, of plastic produced per year. So for every 1 year, like I was saying, United States from 1985 to 2003. So I think that's D. C would just, I know it seems like kind of weird and like it may be right, but D is just a better answer of slope, and remember that's what you're looking for. So let's do number 22, a percent question. And I have to clear this. So which of the following is closest to the percent increase in billions of pounds of plastic produced in the United States from 2000 to 2003? So for this problem, you just need to know how to calculate percent increases. So let's see, from 2000 to 2003. So what we're gonna do, I'm gonna write the equation. I'm gonna write the equation because obviously it's on a different page. But really what you're gonna do is you're gonna plug in the value for 2000. You're gonna plug in the value for 2000, and I think it said 2003. Yes, 2003, and then you're gonna compare using percent increase. So remember that you're not plugging in 2000, you're plugging in, because remember the units are years away from 1985, or number of years. So 2000 is 15 years away from 1985. So what I'm gonna do is plug in 15 here, And then the other one, 2003, that is 18 years away from 1985. So I'm gonna plug that in. I'm sorry it's not as messy. It's kind of hard to write on the screen. All right. So really that's what you're gonna be doing. So when I did that, I ended up getting that this would be equal to 100 and that this one would be equal to 107. So the percent increase. Well, a percent increase is determined by percent increases are determined by using the original amount as your base. So our original amount is 100 because 100 our 2000 comes before 2003, of course. So this is our original amount. In order to determine the increase, we do 107 minus 100. You know, we're seeing how much it increased by in comparison to the original amount, which is 100. And it's saying which of the following is closest. So I know that when we do this, we get 7 over 100, which is obviously 17%. But it's asking which one is the closest to the percent. And really, these are all very like exuberant, like they're very, very high off. So the only one that's close is A. So that would be the answer to that problem. I hope that made sense, and I hope that was a good review of percents. All right. So let's see. We're running short on time. I wanted to do at least one of the long response ones. I'm sorry. Well, at least the long responses in this were not as bad as others. So what I'm gonna do is I'm gonna just move on to the long responses. Yeah, I'm sorry. I really do like multiple choice because I think it's a little bit harder than the long responses. But yeah, I think it's important to do them just because we didn't do any today. All right, so let's do one of these. I'm gonna do 34 because 31, 32, and 33 are not too bad. All right, so 34. On April 18th, 1775, Paul Revere, so I guess they put in history too, whatever, it's a weird problem, set off on his midnight ride from Charleston to Lexington. If he had ridden straight to Lexington without stopping, he would have traveled 11 miles in 26 minutes. In such a ride, what would the average speed of his horse have been to the nearest tenth of a mile per hour? So, really, I think this is more of like a proportion question, only because it's really easy to set this up. You just need to know how to do it. So, we know that 11 miles here, would go over there, and then we have 26 minutes over here. And now we're going to be using this to compare it to what we have over here. So 60 minutes would be in the hour that we're looking for. And the minutes, or the miles they travel, the miles, would be what we're missing. Because we're trying to figure out his average speed for 60 minutes, which would be 1 hour. Because it's saying average speed of his horse to the nearest per hour. So really all you have to do is just you'd have to cross multiply and then divide. So really you just have 26x over here, and you have 11 times 60. This is something you can definitely do on your calculator. I highly recommend it. It shouldn't take too long if you do it on the calculator. And then you divide 660 by 26. So when you do that, all right, you get 25.3846. So really all we have to do now is just round it to the nearest tenth of a mile, because that's what it says. So this would be rounded to 25.4, and it ends up being miles per hour, because this is the amount of miles you traveled in 1 hour, 60 minutes. So that would be the unit, miles per hour, because that's 1 hour. So that's what you would get. And then now the last one that I want to do for today, it harkens back to something that we did a long time ago, or maybe in the first session. So let's look at 36. In triangle RST above, point W not shown lies on RT. So I'm just gonna draw it, whatever, RT, point W. So what is the value of cosine of RSW minus the sine of WST? So point W, let's see. So let's say I'm gonna draw it out over here just so it's bigger because that picture is a little bit tiny. So it's asking for the cosine of RSW, which would be like over here, which is gonna be like that. And then the sine of WST, which is gonna be like over here. That would be WST. And I'm just gonna write it out just so it's easier for me to keep track of what I'm saying. So yeah, this goes back to a very it's a concept that we said earlier. So let's see. It's telling us that this is 90 degrees. So and it's giving us two separate angles. So this is one, this is half of 90. Well, it doesn't even have to be half of 90. It just has to be a part of 90. And this is going to be another part of 90. So just for numerical purposes, I'm just going to say that this is 30 and this is 60. Just so that it's easier, because sometimes with numbers it's a lot easier to picture it. So really you just need to remember that if we're going back to the right triangle trigonometry, there's a rule that says that the sine of one angle is equal to the cosine of that angle minus of 90 minus that angle. So like kind of the opposite. And it looks like this, let's say that we're doing the cosine of RSW, and the same thing works the other way around. The cosine of x is equal to the sine of 90 minus x. That's a really important geometric principle. So here, if the cosine of 30, that would be essentially the angle for the yellow one that we just did. Really, the sine, well, I'm noticing that the sine right there is 60, which means that this would be equal to 90 minus the 30, the x, which is sine of 60, which is exactly the angle that we have here. So you just need to know that since you're splitting up a 90-degree angle, and one of them is going to be cosine, one of them is going to be sine, they're really the same. They're equal. So since they're the same value, it's like you're subtracting like 1 minus 1 or x minus x. The answer is 0 because they're the same value.